All right. So, welcome guys. We're having to redo this session because as I found out, it wasn't even anybody's fault. It was the Microsoft Teams. For whatever reason, it did not record the part where I was sharing the whiteboard and drawing something on the screen and all that. If you remember, Taiwo. So that part was not recorded. I thought maybe my screen was not showing, but when I checked back today, it turns out that the Microsoft Teams is the problem. So it doesn't record whiteboard. So I have to find a way around that because I mean the recording is very important. Um, let me should I share my screen? No, actually, let me just get started. So previously, I think we have covered some of the we've covered some of the basic we've covered some of the basic things. We've gone through most of the beginner stuff that we needed to go through. And today we're getting into Python. And then we'll write some actual code today. So the main goal of the meeting is at the end of it, at least we'll be able to know how to write a little bit of Python code, a block of Python code. All right. So you can think of Python as a little app or a little assistant living inside your computer, and then when you open it, it just sits there waiting for you to say, to tell you what to do. It basically telling you, hey, I'm ready, tell me what to do, right? And I'll show you how to open the Python application on your computer in a bit and how to interact with it. Now, how do we talk to the Python application? Well, on pretty much any computer, whether you're on a Mac, whether you're on a Windows or you're on a Linux, there is a way to open up Python on your computer called the interactive mode, right? Now, the interactive mode is one way to use Python. There is another way that we'll get to, but the interactive mode is the simplest way that you can start with Python. It just means that I'm gonna share my screen a little bit now. Let me show you how to open up the Python application. Um, Let me know when you can see my screen. Still not yet.
Yeah, your screen is showing now.
All right, cool. So I'm on a Mac, right? So on a Mac, we have a terminal app on the Mac. If I want to open it, I know I just need to find it in this folder, and I'm gonna open up. Oh, actually have Python open on it, so I'm gonna quit and I'm gonna open it up again just to make sure nobody gets confused with that step. So this is a terminal app on my laptop, and that's basically one way to interact with Python. So I'm going to just type Python. here, and it should open up Python. Oh, but it doesn't. And this can happen to you as well, You can do everything right and it still fail, right? So, but because I've encountered this problem before, I have a little bit an idea of what's happening. Now, when I type Python in my terminal, it's supposed to open Python, but it doesn't. And that's because on a Mac, it works a little bit differently. So on a Mac, it's not just called Python, because Mac, especially the more recent versions of Mac, if you have like a Mac 2020, 2022, all those kind of Mac, you will encounter this problem. But if you're using an older Mac, you're not going to encounter this problem. If you're on a Windows, you're not going to encounter this problem. But on the newer MacBooks, the Python that is installed, there is a Python that is installed already from the factory, and it's called Python 3. I had to do a little bit of Googling to find out this. So if you encounter this problem, that's totally fine. So it's called Python 3, and that's because some older Mac come with Python 2, Python 1, and all of that stuff. So they needed to differentiate those different versions of Python. So that's why it has this 3 on it. So if I type the correct thing, which is Python 3, and I hit enter, I'm going to see that my Python application opens up, and then I can start interacting with Python. All right, so before I start interacting with Python, let me go ahead and share just my terminal so that Windows Python share. Can you still see my screen?
Yes, please.
All right, cool. So, like I said, this is the interactive mode. There is a different way to use Python, and I'm going to show you that in a bit. But this just means that, when you open Python on your laptop, you can actually, start writing Python code, right? It just Python. We've opened Python up, and like I said, Python is just sitting here showing us this little 3 arrows called prompt. I think there is another word for that thing. Yeah, let's just ignore it. But just know it's a prompt prompting you to type in commands. So that's exactly what this is. So Python is asking us, what do you want to do next? I'm here. I'm ready for you. What do you want me to do? So Python is basically waiting to take our commands so that it can execute those commands. Whether we're trying to calculate something, whether we're trying to, you know, uh, process some files or do some other tasks, Python can do all of that for us, right? So I'm going to show you an example. At this point, we can start typing in commands and Python will respond instantly, right? So for example,
Hello.
I can, pardon?
Yeah, I wanted to say something. Can I?
Yeah, go ahead, please.
Okay, so I've realized that with CMD on Windows PC, when you type Python, it comes. When you do Python 3, it still comes.
Oh, okay. That's interesting. Yeah, I mean, so those are the kind of things you find out, when you're, when you just play around with your stuff, you can find those kind of things out. So obviously, it looks like on Windows, they have two aliases for Python. So normal Python will work, and then if you have Python 3 installed, you can also just type Python 3 and it will also work. And if you type normal Python, it will still open up your Python 3 that you install. So I think that's probably what's going on. So you can basically type anything in here, right? If you type the wrong thing, it will just tell you that you've typed the wrong thing. And it's okay to type the wrong thing. Try to break it, and just play with it and see what it can do and what it cannot do, right? So for instance, I can just type something like 1, and then Python, it brings 1 back. But just typing 1 into Python it's not a Python code, right? So I would normally do something like this: x equals to 1. So you will notice that now Python did not print 1 for us. Why? Because when we give Python 1, it's just the value. So Python will give us the value back. Why? Because we did not tell Python what to do with this value, right? So you can basically type anything here and Python will bring it back, unless it's something that is, it has some problems with, like maybe if you type some stupid thing, it will throw up an error, right? Okay, let me clear this. So like I was trying to explain to you, we had something like this. So you will notice that here Python did not bring back our value. That's because now we actually written a valid Python code. So this is a valid Python code. And I'm going to explain to you what is happening here in a bit. So when we type x equals to 1, we are assigning the number 1 to the variable x. Yeah. So now, don't feel confused, because we have started getting into Python, and you're going to hear some words, that you are probably not familiar with. Don't panic. This is the opportunity to actually get to learn some of those things, and then even if you don't get it the first time, you're going to be able to get it eventually. So what is happening here? um we are telling Python in a very simple way. We are telling Python, hey Python, here is a value 1. All right, this is a value 1, and I want you to go into my laptop, check if I have some memory or some storage. If you find any space on my laptop, I want you to uh, make a space and then label it X, right? And then save 1 in that space. So that's literally what Python, that's literally what we have asked Python to do. So Python takes this 1 as a value, and we said check in our laptop if there is any space. If we have any storage space. Of course, you always have some storage space, your memory, your RAM, your hard drive, your SSD, all those things are the memory on your laptop that Python can access, right? And then we're saying, hey, find a space somewhere and then label it X and then put 1 in there. So Python takes this 1 as the value. It goes into our laptop, checks the memory. It makes a little bit of small space, very small space that is enough to store this information, and then it names that space X, and then it puts 1 in there. So right now it doesn't bring any value for us because we would not ask it to bring the value, but we ask it to take 1 and then save it somewhere in our laptop. So this is called a value. The 1 here now, this is a value. And then this X now, this is a variable. And then this equal sign, we call it assignment in Python. If you're coming from mathematics background, you will probably, be a little bit confused because what we are explaining is different from what this normally means in mathematics, right? So in mathematics, this usually means x equals to 1, means x and 1, they are the same thing, right? That's the normal meaning. But in Python, it works a little bit differently, and there is a lot of similarities between how these things work in mathematics and how they work in Python, but there is some difference, and it kind of makes sense to know them from this stage, right? Right now, we are assigning the number 1 to the variable x. We are not literally saying that x and 1 are the same thing. We are just saying that take 1, make a space on the laptop, label it x, save 1 in there. So you see that's the way Python understands this thing, right? Which is different from the way it works in mathematics. So if you can actually, like physically go into my laptop right now and you have the correct tools, you can actually find the storage. You can actually locate the storage location where Python have called that Python have labeled X. You can locate a place in the storage location of my laptop right now that Python have labeled X. And then if you open that space, you will see that 1 is inside it. We can put more things inside that storage location. For instance, we can say X equals to 2. So at this stage, what Python does is it goes back to that location. It changes whatever is in there. It changes it. So it removes the 1 and then it puts 2. So if we say x equals to Augustine, that's going to throw up an error because Augustine is a word, it's not a number. If we want to save words in Python, we need to put them in asterisks like this so that Python will know this is not a number. This is not a mathematical stuff. So that's the way it works in Python. If it's just a number, you don't need to put this parenthesis, right? So, but now what happens? You can see now Python will go to the same location where it has already labeled X, and then it will replace whatever is in there with the new stuff. So like this, I can keep on changing the value, or I can even create a new one. I can say Y equals to Frank, right? Now we have 2 locations on our computer. We have 2 different locations on our computer that we have, we have manipulated. We have asked Python to call them different names and save something inside there. Now, this is where it becomes interesting because now we can use all these things we have done before to achieve something. Let's say I want to write my full name, and my full name is Augustine Frank. Now I can tell Python to print X, for instance. And Python will go to that location. Remember the location. The location, we've been changing what is inside there. But now Python can go into there And then whatever it finds there, it will print it. So we just telling Python, print whatever is in this location, print it. We can also tell him to print Y. See, Frank. And then we can now do something like print this guy X. Let's see if this is gonna work. Okay, that's an error. We probably need to concatenate it, I think. So if we do something like this, oh, okay. So if we do something like this, we're telling Python to print this guy and also print this guy. And then Python gives us Frank Augustine. And then this is us telling Python, we have these locations on our computer and we have saved something inside there. We want you to go bring what is in there and we want you to print them on the screen. That's what Python did. A programmer might want to put space between Frank and Augustine. Python doesn't know how to do that. So you have to be more creative. So normally we'll do something like this. And now we have Frank Augustine. So, and what we have done is we are asking Python, we told Python to print, to go and check this location, whatever is in there. Also, we now give Python a word, but we did not put any word inside, only is an empty space. So that's the empty space that Python printed out here. And then we now said, there is also another location called X. Find what is inside that memory location and then print it as well. And that's how we got Frank Augustine. There are different ways that a software engineer could use this. Let's say you are collecting people's name on your website, right? And then you've written all the code where they will type their name, their first name and their second name, and then you have another page on your website where you are printing out everybody's name. You will do something like this so that you can get people's first name and their last name together printed on one line. So that's the kind of applications that you will use something like this. But don't even think about that too much. This is just me, showing you a little bit of how you can interact with Python on your laptop as a programmer. If you're able to do this, you're actually already a Python programmer. It's just a matter of, growing from there, kind of learning more complex stuff until you're able to do very complex things with Python, right? So basically, a Python application or a Python software will have, several lines of applications, several lines of code that basically work together to do what you want it to do. It will be do this, do that, do that, do that, do that, do that. And at the end of the day, you will now achieve your goal. That's usually how programming works, right? So in a nutshell, programming is basically a way of thinking, a system of thinking that is compatible with the computer. It's not a way of thinking that comes to us naturally. It's not the normal, it's not something that somebody can just figure out on their own. It's a set of a system of thinking that have already been developed, that have already been written down, that have already been compiled. And then you need to kind of practice it every day, practice it on different things, and then you get used to it. And then eventually it becomes another thing you know how to do. So eventually it will become more complex from doing small things like this. Okay, so like Okay. So I think we have covered a little bit of. Okay, I guess we can also I can also show you a little bit of how to do mathematics, a little bit of maths, right? So I can type clear to clear everything on the terminal, and then remember, if I type x and then I say that x is 1, Python takes note of that. I've created a variable which is basically a space on my laptop, and I named it x, and then I put 1 in there. So I can also do that for y, and now let's say I'm trying to add 1 plus 2. I can do something like x plus y, and then Python will bring out the value. You can also do it like this: print x plus y. Python will do the same thing. So remember, if we are dealing with numbers, Python would work, would see them as, we think that we are doing mathematics, right? Basically, that's what Python would think. So when we say print x plus y, Python knows we are trying to add this number. But remember, we used to have name, like, let's say I have my name here and I create another variable and then I call it Augustine. And then I tell Python to print plus C. What do you think it's gonna do? Anybody? Come on, don't be shy. Um just try. What do you think Python is gonna do now? If we say, hey, Python print x plus y plus c. Remember that x is 1, y is 2, and then c is somebody's name. What do you think Python is gonna do? Okay. Nobody. All right. Let's go ahead and give it a shot, I guess. Yeah, it throws up an error. So why does it throw up an error? Because we have something here. Python knows, okay, this is number, I can add this, but this other thing is not a number. What am I gonna do? Oh, I'm lost. And then it throws up an error telling you, hey, I don't know what the fuck is going on here. All right. So Python is not very smart to know so many things. That's why we have to know them. We need to know that you cannot add 1 plus 2 and then you add the words to it. So you cannot do it in Python. So it will not be supported. It throws up an error and tells you type error, unsupported operand, blah 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 blah. Because we have an integer. This is an integer. And we have a string. This is a string. And it cannot add them together, right? So that's one thing, but if we have another variable and let's call it D, and then we'll call it Frank, then we can tell Python to print D and C. And then now Python is able to print it because they are the same, they are all words. So if they are all numbers, Python is fine. If they are all words, Python is fine. But if you start mixing them together, there's no way Python can add to and Augustine. So you kind of start seeing the pattern of how Python handles things from here, right? Okay. So now this is simple. This is simple, but it's also very, very powerful. What we have just done right now, we have we have been able to store data. We've been able to tell Python, we've been able to manipulate the storage on our laptop, and we stored some data inside of it. And then we retrieved retrieved the data. When you say print, you are retrieving that data that you saved on your laptop. When you say print, we retrieve the data. And we also manipulated the data, by doing all this kind of plus concatenation. We manipulated the data and we're able to print somebody's name. So these are very simple things, but we have actually like achieved a lot. We have actually done some of the most basic, some of the main things that a computer actually does, basically storing data, retrieving data, and manipulating data. And all through your all through your career as a software engineer, that's basically what you're going to be doing with the computer. But it becomes more complex as you move on, as you move up and learn more things and start writing bigger chunks of code. It's simple things like this that when you start writing several lines of code, thousands of lines of code, and putting them all together, that's how we're able to use Python to do so many things. We're able to use Python to control the computer, to control aeroplanes, control missiles, do a lot of high level stuff, So it all starts from these very small things that we've done right now. Okay. So another thing I wanted to show you is you're always going to meet errors, like I've always said. You're always going to meet errors, and it's okay. When you get an error, it's Python who is lost, not you. Python is telling you, I'm lost, save me. I don't understand what's going on. Please correct me. That's what Python is saying. And then with practice, you'll be able to become familiar with some of the most popular error messages that will come across. And then when you see them, they will no longer they will no longer make you panic or something like that. You'll be able to deal with them. Okay, so you can think of learning Python a bit like learning how to write, learning how to read and write. Remember when you were small, when you were a little kid, and then they were teaching you ABCD in school, right? You started from learning the letters. You started from learning A, learning B, learning C. And then after that, they started teaching you how to put those letters together, all those alphabets together to make up words. You started learning simple words like, come, go, take, all those small words. And those are, putting alphabets together, right, to make up words. And then you learn how to put those words together to make up sentences, So Python is like that, right? Eventually, you write an entire essay, you write an entire story, but it all started from learning ABC. That's how it is with Python. We're going to start with the basic stuff, like I've shown you today. This simple stuff, that we've done. Eventually, we're going to learn all the main things, all the basic building block of Python, like the alphabets, the Python vocabulary. We learn Python vocabulary, the Python syntax, and then we learn how to structure it, how to put them together to write a whole Python program, and then eventually you'll be able to write a full software. You know, that's how it's gonna be. So I'm gonna show you what a full block of Python code looks like in a bit, because okay, let me share my screen again. I think I need to share. I need to share my VS Code. Where is VS Code? There's you. All right. So I wanted to show you this code. This is a Python code. This is what a block of Python code looks like. Um, our goal is eventually be able to write something like this, but we will get there in a bit. Remember, you don't need to understand this right now. You don't need to make sense of it. You can look at it, try to read it, try to see if you can understand what's going on here, and that's fine. If you don't get it, our goal is to eventually be able to write a full block of Python code like this that does something. But right now, I just want you to I'm just showing you so that you see what our goal is. Our goal is to eventually be able to achieve this, right? Starting small, starting from the small things that I already shown you. Okay, so now you remember, like I told you, you can run Python interactively, like I showed you, using your terminal and bringing it up, and then you can type commands inside of it, like I did. But there is another way to use Python, to interact with Python, to write Python code and Python software on your laptop. And that's the preferred method. Normally, you would never need to run Python interactively like I did and then type something into it. There are no use cases for that. Maybe there are, but it's not something you would need to do, because the recommended way to run Python's code is to use a text editor like VS Code, like we're doing. And then inside VS Code, you can create files, you can call them whatever you like. When you open VS Code for the first time, you will need to open up a location. When you go to VS Code and you go to open folder, then VS Code will open different locations on your laptop. And it makes sense for you to kind of organize your code, especially if you're getting started, so that you will not mix things up. So you could see on my laptop, I have a folder I called projects, and inside the projects, I have different projects here, but I also have a folder that I call scripts. And inside the scripts, I have a bash and I have a Python folder. So you can organize I can organize all my Python scripts that I'm going to use and learn, or I'm still going to create. I can organize them, all of them inside. I put them all of them inside this folder, and then if I open this folder in VS Code, it will show me all the files that are inside that folder. I can create more files if I want. I can create a new file and I call it test.py. We use .py to denote Python files. If you create a file on your laptop and you call it .py, then your laptop knows that it's a Python file, and then it will be able to treat it like a Python file. So that's how it works. So if I create this file, I can start writing Python code inside it. Remember when we did x plus 1, x plus x equals to 1, x equals to 2. And then we say print, oh, y. This one is y, sorry. X equals to 1, y equals to 2. And then we want to print x plus y, right? So if we want to do the same thing now without running the Python interpreter. We have created a file. We've written our code inside the file, and then we save the file, and then we can go back. We can open up our terminal, and there is a terminal inside of VS Code as well that you can actually use to run your app. It's just like the other one that I opened before. It's just that this one is inside VS Code, so they all do the same thing. As you can see, I can still run my Python from here and it works, right? So, but I don't want to run Python this way. Remember, I can still do my x equals to 1, x equals to 2, and stuff like that. But I want to do it here, right? So I'm going to exit this guy. I'm going to clear, and instead, I've written my code in a file, and then I want to run the file with Python. So I'm going to say Python. So I'm going to say Python because I've written this line on my terminal before. I can use autocomplete. So that's what I did. When I typed py, I hit my arrow key up, my up arrow key, and then Python, and then my terminal can go through my history of the commands that I've typed before, and then it will bring up all these things, and then I can pick instead of me typing the whole thing again. Maybe your laptop does that, maybe your laptop doesn't, but yeah, that's something my laptop does. I guess you can set up your laptop to also have auto completion. All right, so now I'm going to run this app, but it's not called simple.py. I called it test.py. Yeah, that's right. So when I run this file, you see that I get 3. So it means that I can write all my code inside here, plenty code. I can write 1,000 lines of code inside here, and then I can run it once. And then Python will do everything that is in that file and give me the results. So this is a preferred method to use Python. I will encourage you to try both methods so that you become conversant with it and kind of understand things from the very, very basic level. All right. Cool. So like I said, I've just shown you Python code, what it looks like, and we are going to try and achieve this code. Now, this is a simple Python script that um hold on a sec. All right, so this is a simple Python script that takes a file. It opens the file. So the file could be maybe a Word document or something, or a text file on your laptop. And then it opens the file, it counts the words that are inside the file. And then it brings out the words that are most how do I put it? So it's a simple Python script that reads a file. It counts the words inside the file, and then it tells us which word appears the most in the file. Yeah, so it's a practical little um, code that can teach you the basics of opening a file, reading, processing the file, manipulating it, and making sense of the data inside the file. This is kind of like the kind of thing that data engineering data engineers do all the time. And yeah, and coincidentally they use Python for it. Anyway, so don't worry about understanding what is going on here. Like I said, we're gonna come back to it now. I want before we start writing that code, I want to tell you something else. There is something called reserved words in Python, and I wanted to show you a little bit what's the reserved words are. So the reserved words, those are the words that we cannot use in Python. Remember how we labeled this location. We made this variable called x, and we made this variable called y. So we can definitely call this guy anything we like, Tripoli, Lagos, and then it will still work, right? We can call this variable whatever we like, but there are some words that are considered reserved that you cannot use. You cannot use it. If you use it in Python, you're going to get an error. So those are the things we call reserved word. And I'm going to show you those words in a bit. Let me share another screen. Chrome tab, internship, day 4, blah, blah, blah. Okay. All right. So this was the part that caused the problem for me yesterday, actually, but I hope it captures the whiteboard today. So you cannot use any of these words that is written on the screen. You cannot use it to name your variables in Python. Why? Because these words have been reserved for Python internal use. Each of them means something to Python. Each of them means they have something that they do in Python, and there is a specific way to use each of these words. But don't worry, you don't need to memorize any of these words. At least not, it's not necessary, because as you continue to practice coding, you will use a lot of these words. You will learn how they are used, like the if statement, for instance. This is the if. If is a reserved word in Python, and it literally means the same thing it means in English. So sometimes we want to tell Python to only do something if a particular condition is met. That's when we use if. We also have this one called elif, short for else if. So they normally used together. When you tell Python, if this happens, then do this. Then you can also tell Python else, if this other thing happened, then do this other thing. There is even else that you can tell Python that if this thing does not happen, else you can do this other thing. So There is also but these are just um, words that have been programmed into Python to behave in a certain way. So eventually we'll get into how to use each one of these, and then it will kind of practicalize it, and you kind of see how they are used, right? So there will be no need for you to memorize any of these. All right, I'm just showing you. You can think of it kind of like there is a metaphor that I've heard somebody use before to explain the reserved words in Python. It's kind of like a dog, right? If you're familiar with dogs, you will know that people are able to train dogs to kind of hear certain words, right? So, but there is a way that it works with dogs because they don't actually understand what we say. We only teach them to learn certain words. They become familiar with that particular sound. And then whenever you say something, you can say plenty things. You can make a whole sentence. But if that word or that sound is inside your sentence, then the dog is going to hear it. So it's kind of like um, let's say you teach your dog the word um, walk, for instance. It not be maybe you always take your dog to work, and then your dog becomes conversant with the word walk. So whenever you are speaking, it's always going to sound to your dog, hey dog, how are you today? Do you want to go to the park later, or do you want to hold on and let me finish my food so we can go for a walk? Blah 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 blah. Everything you have said sounds to your dog like blah 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 walk blah 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 blah. So that's how your dog perceives it. Once he hears walk, that's a reserved word for your dog. Then it pictures, okay, we are probably going for a walk. So that's kind of like how reserved word works in Python. You can type whatever you like. You can use any other words. You can do Python will not care. It doesn't know all those words. So you can use them and use them to represent your variable. But if you use any of these reserved words, then Python will just know. Oh, give me a sec. I need to switch the light. Sorry about that. Where was I? All right. So those are the reserved words, and I wanted you to know that eventually, if you mistakenly use any of these words, Python is going to throw up an error, and that's how you're going to know that, okay, I made a mistake, and that's totally fine. Okay. All right. So those are the reserved words. As we begin to program, the other thing I want to talk to you about is something called programming patterns, right? I think I have it on this document as well, somewhere here. Yeah. Cool, cool, cool. I'm gonna delete this one. So programming patterns. So there are a few basic think about programming, like I said. as a way of thinking, a system of thinking that you're learning how to do it, right? It's not something that comes to you naturally. It's not something that comes to anybody naturally. It's something that have been invented, have been created and developed over the years, right? So that system of thinking, there are some distinct patterns to it, right? So there are a few basic programming patterns that you're going to come across every now and then, and they are not much. It's actually a few. The first one is called sequential steps. That is one thing after another. So sequentially, Python will go through your code from line one. It runs line one. It runs line two. It runs line three. Let me actually show you what that looks like in real life. Okay. So you remember when we wrote this code, something like this on our Python terminal. This kind of code is the kind of code that Python will run sequentially. Why? Because we are just telling Python line one, x equals to 1. So Python goes about, it runs this. I probably can do better than that. Yeah, so Python goes about, it runs this line. Yeah, that does not work. Okay, does not work. I guess I should use this. So Python goes about, it runs this line. It moves to the next line. It runs this line. It moves to the next line. This is what we call sequential programming pattern. So sequentially, Python will do line one, to go to line two, to go to line three. But that's not always the case, right? There is another pattern in programming that is called conditional steps, right? So for conditionals, Python is going to follow some kind of a condition, right? So these are usually like, that's where we use things like if this happens, do this. If that happens, do this. And we do that a lot in programming because that's how, when you start writing more complex programs, that's kind of like the only way you're going to be able to get things done in that fashion. So I'll show you an example of what that looks like in a bit. Code access, simple. All right. Yes, I have a sample. All right. So let me go ahead and delete this guy. And then let me show you what the conditional type looks like, right? So this is the conditional type. So this is a different pattern of programming. In this case, you will notice that we have one of those reserved words that we just talked about. This one is if. This one is if. So in this scenario, Python, we are telling Python here, hey Python, we have the first line, we have this number called 5, and okay, I wanted to tell you a little bit about how Python runs code. Before I come to this, actually, let me show you something else. Let me show you. Let me show you. Okay, let me show you my VS Code. Hopefully you can see it. Okay. So you remember when we have this little block of code here, right? And then I wanted to show you how Python reads the code that we write. Normally, you would think that Python, starts from line 1, and then it starts from the first word, and then it goes this direction, and then it says it sees equals to, and then it sees 1, and then it continues like that, right? No brainer. But wrong. That's not how Python reads. Python starts from here. It's going to start from line 1, but it starts from the back. So first of all, Python, it gets and this is very important. If you want to understand how to read and write code, give me a sec. Ah, electricity in Nigeria. All right. So if you want to understand how to read Python code, this is very important because you're gonna meet codes. You're gonna get code from ChatGPT. You're gonna get code from other people from different websites, maybe from your boss at work, and you need to, or your colleagues, and you need to read it. You need to make sense of it, right? Python will start from back. It will take this value 1. It will say, oh, okay, this is a value 1. What do you want me to do with this value? And then it meets this guy. Oh, this is an assignment. So you want me to assign this value to something. Where do you want me to assign it? Then it meets this guy. This is a variable, and then it ends this line. It takes this, assigns it to this guy. This line is done. It goes to the next line. It starts from here as well. Again, it sees this value, it gets this value. Okay, what do you want me to do with this value? You want me to assign it to something. Where do you want me to assign it? Assign it to this guy. It does that. Same like that. So that's how Python reads your code. Why is this important? Because when we go to the conditional stuff, when we start talking about the conditional pattern of thinking, then you will meet code like this one. I think I'm still sharing my screen, share my VS Code. So when you start doing conditional pattern of programming, then you will get something like this. Now, this is a simple piece of code that tells Python. Remember, Python is going to start from the back. It gets the value 5. It goes, oh, there is equal sign here. That is an assignment sign in Python. What do you want me to assign it to? X. And then Python comes to the next line. Oh, it means this guy. This guy means something in Python. It means there is going to be an indentation. So once Python sees this, it's going to be expecting an indentation. It's just expecting that there is, this line is not standing alone. There is something that will come under it. All right. So Python is gonna pick this guy 10. It's gonna pick 10, and it says, what am I gonna do with this value 10 that you give me, right? And then it's gonna see this parameter here, and then it's gonna say, oh, okay. So you want me to compare this value? This is less than sign, I think. This is less than sign. So you want me to compare this value with what? What do you want me to compare it to? X. Okay, you want me to compare it with where? X. Ah, okay. And then Python checks X and 10. Which one is bigger than the other? So remember, X is less than 10. Yeah, that's what this means. Okay, so you gave me the number 10, the value 10, and you want me to check if X is less than it. Yes. And then, okay, I have checked it. If X is less than 10, what do you want me to do? I want you to print smaller. And then Python say, oh, okay. So Python goes 5, X is 5. It assigns the value of 5 to X. And then it goes here and it checks if this 5, which is X, is less than 10. And of course, 5 is less than 10. Then Python goes, okay, it runs this line. And then Python comes to the next line, right? It sees this thing and it knows, okay, this line is not alone. There is something coming under it. And then it takes this value 20. What do you want me to do with this value? He said, check if compare this value with X. You say, okay, I know X, X is 5. So what am I comparing here? You said compare if X is greater than the value I gave you. Then Python goes, oh, okay. If X is greater than 20, that's what you want me to check. Then Python checks, and then Python finds out that X, which is 5, is not greater than 20, which means this line is not going to be true. It will not resolve to true. So this is not true. So Python is going to skip this line. It's not going to go ahead and do this. Then it goes to the next line without indentation. So let me just separate them so that you kind of see how it works. So this is a single line, independent line. Python run this line, no problem. It goes to the next one. This is the conditional statement here. This line will only run if this condition is true. This line will only run if this condition is true. This line will run no matter what. Why? Because there is no indentation here, and then Python will always run this line, right? So that's kind of like how it works. What is an indentation in Python? Indentation is a way that we use to signal to Python that this guy and this guy are part of the same code block, that they are working together. This guy and this guy are working together. If we remove that indentation, then Python will no longer consider this guy and this guy together. They will be individual lines. And then this will throw up an error because we already put in a colon here, telling Python that there is a continuation of this line under this guy, right? So Python expects you to have an indentation here. So if I go ahead and I run this file, let's see what Python is going to print out, right? If I go ahead and I run test.py, remember, conditions. So Python will come here, it will check 5, it's assign it to X, right? And then it takes 10, and then it compares 10 with X, and then you want it to check if this is true. That's what you want it to check. That's the condition. And then because X is less than 10, because X is 5 and it's less than 10, then Python goes ahead and runs this code, and which means it's going to print smaller, and that's why we have smaller here, right? Then Python goes, okay, 20, you want me to compare 20 with X. What do you want? Why do you want me to compare it? Because I want to check if it's true. Then Python checks, said, no, this is not true. Then Python skips this guy. Python does not run this one. That's why we did not get it here. So Python goes, skips, right? So it goes to the next line, and then it prints done. That's why we get done here. So that's how you read your Python code from the back. Eventually, you become familiar with most of the terms, and all these things start looking like very simple stuff. So, but I just wanted to show you that, and I wanted to show you. Yeah. So I wanted to show you that guy here. What it looks like in reality, right? Yeah. So for the sequential step, it just goes this. But for the conditional, which we are trying to, understand a little bit more today, right? Python goes from here. This will be a sequential step, simple step, and then it goes to the next guy, right? Then Python runs this guy because they are all together. Because this code block is together because of the indentation and this colon sign here. Then Python checks if it's going to run this guy. Because this one evaluates to true. Python runs this guy. Then Python comes to the next guy. So Python checks this guy. And because this one is not true, Python does not run it. So Python moves from here to here. Yeah, I'm not good in drawing, I guess. So Python goes here. So Python comes here, and then it jumps from here to here. All right. That's what Python does. Okay, so that's just what I wanted to show you. So this is the conditional steps. This is a different pattern of programming. One of the other pattern of programming, and you will come across this one a lot because we use conditional statements a lot, because program is always computer trying to make a decision. Should I go right or should I go left? And it's all these conditions that tells computer to go right or left. Imagine something like a Tesla self-driving car. It will be a code like this that is running it. It will probably be something like it will tell the car, if you get to a junction, how does the car determine whether to go left or right? So those are the conditional statements. So the car will probably go through some conditions, maybe check the direction on the map or something like that, and then it will use that information to decide whether to go right or left. So we use conditional statements a lot, and we use it to achieve very high level stuff, right? Cool. So The other pattern of programming that I wanted to tell you is loops. All right. Let me go ahead and clean this out. Yeah, so the next one is loops. Loops. So loops is another pattern, but loops is kind of like conditional statements, except it repeats. It repeats as long as the condition is true. It keeps on repeating until the condition is no longer true. So I will show you an example. So in loops, where we repeat something many times, I'll show you an example of how we do that. I'm going to share my VS Code again. My test.py, that's it. So let me show you, let me show you an example of a loop. Okay, so this is what a loop looks like in Python. So loops are this is one of the Python reserved word. You will see it in that reserved screenshots that I showed you earlier. So remember, we want to read this code, right? Just the way Python will read it. We'll start from here. So we give Python a value 5, right? And then Python takes the value 5 and then it says, what do you want me to do with 5? There is an assignment here. It says, oh, okay, you want me to assign it. Where do you want me to assign it to? Assign it to a variable named n. And Python is like, oh, okay, I can do that. So it does that. You know, no issues. It does that pretty fast, no issues. And then it comes to line 2. It starts from here, right? And then it meets this colon here, and then it goes, wow, that's a colon. That means something must be coming below. This is not the whole line, right? So it begins to expect an indentation, right? So that's what this colon tells Python. And then it goes to the next value, and which is 0, and it says, oh, this is a value. What do you want me to do with this value? Then it goes here. It sees this sign and it says, oh, comparison. You want me to compare this to this to find out if it's greater. You want me to compare 0 to n, which is 5. N is 5. And you want me to compare whether 5 is greater than 0. Of course, 5 is greater than 0. So what? And then it goes here. You see while. So we are just telling Python while n, which is 5, is greater than 0, do whatever I say. You know, do whatever is in here. Do whatever is under this statement. And this is a condition, but not, remember, if we can do like if here, like we did before, but we are doing while. So while, we are just telling Python that while this is true, continue to do what is here. So as long as this statement is true, Python is going to continue to do what is here. And what is here? Python will come here and it says print n. Oh, okay, you want me to print the value of n, right? So Python will keep on printing the value of n as long as this thing is true. And let me show you what that looks like in a bit. So if I run this, if I run our code right now, then we'll find out very quickly why it's such a bad idea to do something like this. Because what is going on here? You see that Python continues to print 5. And if I don't shut my laptop down or somehow figure a way to stop Python now, I have gotten into something called infinity loop. in Python, which is something that people usually do mistakenly, right? So while loops are very helpful, they can get you in trouble sometimes. So imagine if this is an aeroplane and you manage to make this kind of mistake. The aeroplane will fly forever. It will probably fly out of space and continue to fly till reach Pluto or till it's destroyed completely. So that's the kind of thing that is going on here. So we are just telling Python, as long as this guy is true, continue to print n, and that's what Python is gonna do. So that's but we don't want to do that. So I'm gonna do Control D here to see if I can stop this guy. Control D doesn't work. I have to quit. I have to find a way to quit this thing. I'm gonna open it again from scratch. So we have learned not to do, we have learned quickly that this is a loop that will continue to go until this guy, as long as this guy is true, to continue to go. So unless this guy stops being true, that's when it will stop printing n. And that's kind of bring us to the next line. So we'll normally do something like this in every while loop. In every loop, basically, you have something like, you must have something like this. Otherwise, the loop is going to run forever. So remember, Python gets 5, it saves it, it comes here, it gets 0, it compares it with n, and we tell it while n is greater than 0, prints n, it prints n, and then it comes here, it gets 1. What do you want us to do with 1? We want it to minus 1 from n. What is n? N is 5. Okay. After I've minus 1 from n, what do you want me to do? We want you to save it as the new value of n. So remember, Python comes here, it takes 5, it assigns 5 to n, it comes here, it checks whether n is greater than 0, and that's true. So it prints n. First of all, n is 5, so it prints 5, right? And then this line will make it to remove 1 from 5, which means at this, once Python run this line, then n becomes 4, right? Because 5 minus 1 is 4. Then, even though it's 4, 4 is still greater than 0. So it will continue to run. So it will go back here to run again. But at this point, n is 4. So it comes here, it prints 4. It comes here, it removes 1 from 4. Then it becomes 3, Abi. Then it goes back. It will continue to do it until it reaches 0. So when it goes for the third time, n is 3, it removes 1 again, n is 2, it removes 1 again, n is 1, it removes 1 again, n becomes 0. And then once n becomes 0, it will go back here and then it will check. It will now see that n is no longer greater than 0. And that's when it will get out of this loop. And then it will continue the next line. And that's how a loop works. So now with this small line of code here, we can run this code without getting into trouble. So if we run this code, you're going to see that it's just going to count down from 5, like I said. And then it will run the code and it will finish the code, and it will not get into infinity loop, right? So what is going on here? This is 5, right? And then 5 is assigned to n, and then while n is greater than 0, it prints the value of n. So it prints 5 the first time, then it removes 1 from 5, it prints it, it removes 1 from 5, it checks whether that number is still greater than 0, and it's true. So it prints it 4, and then it removes 1, from 4. He gets 3. He goes back, he checks. Is 3 greater than 0? Yes. He prints 3. Here. And then he removes 1 from 3, like that. He goes back, checks. He prints 2. He removes 1 from 2. He goes back, he checks. He prints 1. He removes 1 from 1. He goes back, he checks. Now n is 0. It becomes 0 because 1 minus 1 is 0, right? Then he checks. Now n is no longer greater than 0. So it skips this whole entire thing. And then it goes to the next line. So it prints blast off. And that's how we get blast off here. So that's the loop, the pattern of programming called loops. And we use loops a lot, just like conditional statements. We use a lot of loops. You're going to do a lot of loops, as a software engineer. All those things where you meet on websites whereby maybe it's counting down. That's how we do it. Or maybe it's telling you to wait. Maybe you're watching YouTube video and then you see that little button that tells you to wait for how many minutes while the advert is playing. These are the kind of thing that does it. You basically tell the program that, okay, wait for 5 minutes. And maybe during that 5 minutes, it's counting down 5, 4, 3, 2, 1, 0. And then the button changes to skip ad. And then you can now skip the ad. So that's how we do those kind of things, right? Practical stuff. Cool. So I just wanted to show you that and also show you what it actually looks like when you are. Let me show you what it actually looks like on the whiteboard as well. Yeah, so when we have a conditional statement, like I showed you earlier, we have a conditional statement like this. Python will run this guy, no problem, and then it goes to the next one, right? This is a block of code. So, but it continues to run this code as long as necessary. Continue to run this code as long as necessary. Continues to run this code. So this is a loop. That's why I'm doing this. It's my stupid drawing, right? So it continues to go like that, until this is no longer true, right? So once this is no longer true, that's when it goes to this guy. So that's a loop. That's a loop. Now, the other thing is storing and retrieving data, but that one is more like a technical stuff. We are going to get to it. It's not really a pattern of thinking or a pattern of programming. It's more like one of the things you will learn, how to store and retrieve data, on files on your computer. One of the things we are going to learn like that. Okay, I'm gonna stop sharing. And I hope we learned so much about loops and conditions and things like that. So as you get more advanced, you start um, okay. As we move forward, right, you will start seeing um, more complex patterns. There's something we call nesting in Python, and that's when you have a block of code. Under it, you have more code. Under it, you have more code. Imagine having indentation that goes like this and goes like this and go like you have code inside code and inside code and inside code. And we use all this for loop, all this while loop, all of these things together to achieve more complex code. But as soon as you understand it at the basic level, like the sky is your limit. You'll be able to write very, very complex code, solve complex problems. So we'll get into those things in the future. But right now, just try to understand this basic concept that we're going through, and remember that like I told you, you don't have to internalize, you don't need to internalize them all at once. You can always go back to this video, replay it. You can always, um just do a little bit more research on your own, and then practice and do things that are outside of what we have shown in the video, so that you kind of become used to this thing, because it takes practice, not just learning. Don't you try to memorize anything I've said. Don't you ever try to memorize any of the things that I said. That will be the wrongest way to learn it. Practice it instead. Practice, just give yourself small problems, practice it. There are going to be assignments, of course, on all these things, and then try those assignments and go outside of your assignments, and try out your own stuff. And practice is what makes you perfect as a programmer. There is no other way. You cannot memorize any of these things. You should not. Maybe you can, maybe you're good in memorization, but I've seen folks who try to do memorization, write something down, look at it many times and all that stuff, and it doesn't work, because programming builds on the basic stuff. Eventually, it becomes so complex that if you miss a thing because you're just memorizing it, it will be a big problem for you, right? So just don't overthink it. Just practice, and that will be all. Hopefully, that will be all you need to do. So the big idea behind programming is basically combining simple patterns like this, and you know doing these things in order, like doing one after the other, which is the sequential, you know, or making decisions based on some conditions, like we have seen with the if statement, or repeating actions like we have seen with the while loop, and then building all of them together to create a complex code that does complex tasks. That's basically what programming is all about, right? The rest part of it is just you building up your skill by practicing these things every day, and then getting better at it. But don't worry, if you're not getting it yet, you're definitely gonna get it, as long as you don't just push it away and be like, I'm not understanding this thing. As long as you take a break, take a walk, and then you come back to it, it will make sense. It will start to make sense. Okay. This is probably enough for today. I think we can stop here, and then we can talk about any other thing. So do you guys have any questions for me? I know I've been going on and on and on for more than an hour. So any questions?
Thank thank you so much. This is a safe class actually. This is going to 2 hours of talking, explaining, giving insight. Thank you so much. I'm so impressed. Thank you so much. This worth
Yep.
thousands of dollars. This worth thousands of dollars. So by God's grace, I will reach out to you tomorrow if there's anything I find difficult while I'm trying to put it into practical. I'll definitely reach out tomorrow by God's grace. That's for my end. Thank you so much. I do
Yeah,
appreciate.
yeah. I think we already spent a lot of time here. So maybe tomorrow we can have that session and just go over whatever problem you guys are having before we start scheduling the next class. All right. Maybe tomorrow, if you have time tomorrow, we can look at your Git issue or whatever, and then I think there is other guy who is having access. access issues as well. So I guess we can do that tomorrow if I have some time. I'm not sure yet, but we'll see. All right, guys. Thanks for showing up today. I guess it's already a lot of time spent. So I just want to let you guys go so that I can also get some rest. So enjoy the rest of your day. Okay.
Okay, thank
If
you
you
so
have
much.
yeah, if you have any other thing you want to say or any other question, you can drop it in the chat. All right.
Okay,
Bye. Take care.
bye.